Another thing you may be wondering, or kind of really anyone wondering, is just how big is that population? Right? Is that population growing? Is it declining? Is it staying the same? Is it a lot? Is it a little? Are they going endangered? Knowing how large a population is incredibly important. I mean, humans are kind of obsessed with this. We're really obsessed with the human population. We're at like 7.5 billion people. We're also kind of obsessed with how many animals there are. There's, 20,000 orangutans left in the world. There's, 1 million of these pelicans in the world. We like knowing how large populations are, and we can grab a lot of information from that. So let's say I give you this picture. How many penguins are there? Yeah, right? Like I don't expect you to actually count that. That will not be on the review quiz. But who knows, right? I could spend my entire day measuring that. I could sit here and go 1, 2, 3, 4, 5, 6, 7, 8, but that is not viable. That doesn't make sense to do. I'd be wasting my time, and as a researcher, as a scientist, you're also wasting money spending so much time to estimate a population, especially something as big as this. So what do we do then? Like how do we make this more manageable? So one thing we can do is we can grid this off. We can use a grid, and instead of counting every single penguin in this colony, instead we can count some of these boxes. I can count the number of penguins in this box, or the number of penguins in this box, or in this box. Now you can see this image is not equal. You only have a couple penguins in the front because they're closer, so they're bigger, and you've got a lot more in the back. Also, these grids are half penguin, half picture, so that's not really even either. So you have to kind of develop some rules for this. So scientists actually do this all the time. They will grid off their ecosystem, they will grid off their population, and then they choose a random box to count, or multiple boxes. Typically, your goal is to measure 10% of the area. So for example, we've got 7 by 6, that's 42 boxes, so we should count 4 to 5 boxes. Now the boxes you count should be random. I don't want to take the easy way. If I were to count these 5 boxes, well, that's not going to be really accurate of my ecosystem. If I count, these 5 boxes, that also won't be accurate. And so what scientists will do, and you've kind of seen me do this, is use a random number generator. So they would mark each of these. This would be 1, 2, 3, 4, 5, etc. And then they would use a random number generator and choose their squares that way. So for example, they might have chosen 1, and then maybe the number like 10, I don't know what these are. This one came up, this one came up, and this one came up. Whatever the number generator said. Because it's random. You, the researcher, have bias. Hell yeah, I'm lazy. I want to record these down here. It's going to be so much easier. But that's not accurate. And we're trying to be as accurate as possible. So we are just randomly choosing places and not trying to choose things that are interesting, things that are easy, things that are difficult. We're trying to get a mix of everything. So that's one way scientists will measure the size of a population. And again, a lot of the reasons we do this is because we're interested in how the population changes. For example, this researcher is looking at coral and is looking at the coral dying. And so here they have this grid, and they're doing the same thing for this grid. They are looking at the percentage of dead coral in each of those boxes. But they're not going to count every single box. Instead, they're going to count this box and say, oh, okay, within this box, a really good estimate is 62% of this box has dead coral in it. Or, this has, 21% dead coral. So they're kind of using this to see over time, like how is our habitat changing? How are organisms changing because of that? So really, really important skill to have to be able to estimate populations, because it's not something you do once and that's it. Yeah, coral's good. We don't do that. We measure it multiple times to see how things change. So that's great if you have a really big population, or you have a population that's sessile, so isn't moving. Those penguins, they're breeding, they're not moving much. I can take a picture and start counting. But what if you're measuring something that you don't have that luxury? Let's say you're looking at migratory whales. You might be able to find one pod of whales and say, oh, there's 8 in there, but I'll tell you right now, there's more than 8 whales in the world. So what do you do? So we have this equation, an easy equation, so don't worry too much. We have an equation that kind of helps us determine or really estimate how large our population is. Now that equation is referred to as the mark and recapture equation. By mark, I literally mean marking it. That organism you're going to mark in some way. And that's what you see here in this picture. We have different gastropods marked with different identifying numbers. We're going to release them into the wild, and we're going to try to recapture them. And depending on how many we recapture will be how many, or will help us with our estimate of how many we think there are. So briefly, talk about it more in a second, but briefly, we're going to sample the population once. I went out, I saw that pod of 8 whales, and I marked them. And we'll talk about how to mark them in a little bit. Then I release them. And I go back the next day and I sample again, and oh, I found a pod with 10 whales, and oh, there's actually 3 whales that are marked the day before. And that's what gives us the clue and gives us the ability to estimate the population size. So let's walk through an example of how to use this equation. So I'm going to give you the equation first, and I'll kind of explain it, and explain it more as we talk about the example. So the equation, which I would give you, but I wouldn't tell you what it means, is m over n equals r over t. If you like simplifying things, you can, but I keep it in this form for a reason, because I think it's easier to remember what everything is for a reason. So as I mentioned, the first thing you're going to do is you're going to go out and you're going to sample. So I went out and I saw those 8 whales. M are the ones that we marked. These are the ones I originally saw, and I marked them. So I'm just going to write in this 8. T is the number that I saw the second time around. So in my example, I went out, saw 8 the first day, came back home. The next day I go out and I found 11 whales. Well, of those 11 whales, I only saw 3. And that's what the R is. R is for recapture. So M is for marked. R is how many I recaptured the second time. So T for time. And we are solving for N. We are solving for the number, or really in this case, our estimate of the number of organisms in this species. So to solve this, you can cross multiply. So 8 times 11 is 88 equals 3 times n. And n equals, that should be about 29.66. Let me check that real quick. So let's see, 88 divided by 3. Yep, I was close. 29.33. Well, we don't have 29.33 whales, so in actuality, this is 30, right? I'm not estimating I have 29 and a third whale. I'm estimating I have 30 whales. And that's really important when we're talking about these population calculations, because it's important to note that, yeah, I recognize there is not a partial whale out there. Now, the way this equation works, a way to remember it, because you're like, I don't want to remember what M means and N and R and T. The way it works is we marked 8 individuals. And when we go out the second day, we're actually creating a ratio. We're saying, hey, for every 11 that we found, 3 of them were ones we've seen before. And so if you go back to the left side of this equation, we're saying, oh, Well, there's 8 we've seen before. What is this number? You know, how many were there? And here's how much I'm seeing. So in this case, we're saying n is 30. This is the same proportion. 3 divided by 11 is the same thing as 8 divided by 30. We're saying that anytime you go out and see some whales, there's a certain percentage that you've already seen before. And we can use that to estimate. So this is essentially a ratio. This is saying, here's how many we saw out of this many individuals. Here's how many we saw out of this many individuals. This was from our second time. This is from our first time. We're just solving how many individuals were there with this first time. So that's kind of how the equation works. Maybe that'll help you in remembering like where these different numbers go. So let's do this with a different example. Okay. So I'm going out, I'm looking for spotted salamanders. And I went out to a forest and I was looking in this one area and I was looking there for about an hour and I found 7 and I marked them. And maybe I marked them by putting like a metal band on their arm or something. So I marked them, and that's my M, right? M is for mark. And then I put them back in the environment to let them hang out with their friends again, to go back to their home, to eat, etc. Just want to mark them, throw them back. Then I want to go out again. And so here I've marked them instead of metal bands. I got this red nail polish that I put on them. So I'm going to go out again. And I'm going to survey that same exact area again. And you also need to spend the same amount of time, right? If I'm out there 1 hour one day and 5 hours the next day, well, that's not going to be very equivalent, right? I spent 4 extra hours searching for them. So same time, same area, try to keep as many variables the same as possible. And I'm going to do the same thing. I'm going to look for more salamanders. Can I find that same species of salamander? And I start looking and I'm looking, and I did find them. I found 4 of them. And of those 4, one of them I've recaptured. One of them had this red dot on it, or its silver band on it. And I'm like, oh, I've seen this one before. So my number is 4 for T. That's how many I caught the second time. And 1 for R. I only recaptured 1. So what I'm saying is I went out, caught 1 out of 4 individuals. So that's what I'm going to use as my ratio. So when I go out, 1 I've seen before, and there was 3 new ones, or 4 total. I originally saw 7, so the question is what is this number? If this is 1 out of 4, 7 divided by what? Now you could do 7 times 4 equals 28 equals 1n. So this was an easy one. I can just write 28 in here. We're saying that, yeah, there was actually 28 the first time. You just happened to catch 7. And the second time, yeah, there was 4 out there. You just happen to catch 1 of them. So that's kind of how this equation works. Now I keep saying we can mark them, but depending on the organism, it's going to be very different how you mark them. We should not use fingernail polish on a salamander. Salamanders kind of breathe and use their skin as an organ. We could use, say, nail polish on a snail. That shell doesn't allow gas exchange or anything like that, so as far as we know, won't affect them. With whales, that would be a lot of work to catch them and put a tag or a marker on them. But whales, their tail fins, like you see here, are actually very unique to each individual. They have a special signature similar to the fingerprint of a human. And so people doing mark and recapture with whales or following a whale pod will take pictures of their tails and kind of have a book of like, oh yeah, that's Frank. I've got that. I've seen that whale before. Oh, that's a new whale. I don't have that fingerprint in here. Some organisms you might remove part of them, or the mark and recapture I've done, we cut their ear a little bit. Some organisms, like mice, have no nerve endings in their ear. So they actually don't feel it at all. It's like, I don't know, kind of like our earlobes. Our cartilage hurts a lot, but our earlobes, for the most part, like don't really hurt when you squeeze them really tight or anything like that. So we might take a chunk out, or we might cut it just to be like, yes, I've seen this one before. Some conventional tagging, like literally putting a tag on them, Or what I've also seen and what I've done is literally shaving a qualifier into the organism. So just shaving their hair a little bit just to recognize, you know what, this is organism number 22. I'm going to guarantee this animal did not have a 22 shaved into the side of them before I marked them. So just different types of techniques. It's important just to keep in mind your organism. It doesn't make sense to paint the nails of this organism because more than likely those nails are going to fall off. You don't want to disturb the organism or disturb the mating rituals of an organism. So different things that scientists have to keep in mind. It's not simply, oh, we'll mark it. Like, you really, really have to think about that. All right, so that's where the lecture is going to stop. I have this last example up here that you can find in the PowerPoint slides. But I'm going to have you guys do this as homework, and then the review quiz for this lecture will have this question on it. So you can pause here and write this down. You can look at it in the slides, or you can just wait until the review quiz and take a look at it there.